Hello students, in this video we are going to learn maxima and minima of a function of two independent variables. So first we see definition of maximum and minimum. So maximum is a function z equals to f of xy of two independent variables is said to have a maximum for x is equals to a, y is equals to b if f of ab is greater than the value of function for every other pair of values of xy in small neighborhood of ab. That is, f of ab is greater than f of a plus h into f of a plus h b plus k for all sufficient values of h and k. It means a function is said to be maximum at a point a and b if there exists a neighborhood. Suppose this is your function, this is a graph of that function. So this function f, it is f, so it is said to be maximum b. So let's, this is a point of maximum, then this is called point of maximum if we draw a neighborhood around that point, then all the points near to them does not have a value greater than this point. Let this is a point AB, then all the points in neighborhood of AB have less value than f of AB. It means f of AB is greater than f of a plus h b plus k. So this is point of maximum. Similarly, minimum is a function z equals to f of xy is said to have a minimum if f of ab is less than the value of functions for every other pair of values of xy in small neighborhood of ab. That means f of ab is less than f of a plus h b plus k for all sufficient values of hk. It means this is our function f, this is the graph of that function. So this is a point AB, then point AB is called minimum point if we, if there is any small neighborhood of AB, then for all other points in that neighborhood f of AB is less than f of a plus h b plus k. So see here, this is f of AB, so this point is AB, and value of f of AB is less than all other points in the neighborhood of AB. So this is minimum point of this function. So now we will find maxima and minima of a function. But for that, first let us see what is the working rule to find maxima and minima. There are certain steps to find maxima and minima. So let z is equals to f of xy is our function, given function. So to find maxima and minima, first step is solve da by f by da by x and da by f by da by y. It means find partial derivatives of f with respect to x and y. Then equate them with 0. Equate these both values with 0. So we get two equations. So solve equations for the x and y, for the value of x and y. So we get value of x and y. So let a1 b1, a2 b2. In this way, these are the pair of values which are for x and y. So these are answers of these two simultaneous equations. After that, second step is calculate r, s and t, where r is dabba square fy dabba x square, s is dabba square f into dabba square f by dabba x into dabba y, and t is dabba square f by dabba y square. It means r is double partial derivative of f with respect to y, t is double partial derivative of f with respect to x, y, and s is First calculate partial derivative of f with respect to y, then calculate partial derivative of f with respect to x. So this is our second step. Now, and calculate these points RST, calculate values of RST at these points, which are a1, b1, a2, b2, means with at the at answer of that simultaneous equations at that points. Calculate RST at these points. Third step is, if RT minus S square, first calculate RT minus S square. If RT minus S square is greater than 0 and R is less than 0 at a1, b1, then f of xy is maximum at that point, and f of a1, b1 is called as maximum value. Second, if RT minus S square is greater than 0 and R is greater than 0 at a1, b1, then f of xy is minimum at the point a1, b1, and value of f of a1, b1 is called minimum value. Third, if RT minus S square at a1, b1 is less than 0 at a1, b1, then f of xy is neither maximum nor minimum point. Such point is called as saddle point. Example means, suppose this is a graph of some function which is of this type. This is a graph of some function. So at this point, our function is neither maximum nor minimum, because its maximum point is this and minimum point is this. So such points are called saddle point. And when RT minus S square is less than 0, then we get saddle point. And if RT minus S square is equals to 0 at a1, b1, no conclusion can be drawn about maximum and minimum. So in this case, we have to evaluate it further to know whether that point is either maximum point or minimum point. So now we will take example to understand maximum and to find maximum and minimum of a function. So this is our function x cube plus y cube minus 3axy. We have to find at which point this function is maximum or minimum. So this is our f of xy. So we will first write our first step, which says that first calculate da by f by da by x, da by f by da by y, and equate them with 0. So da by f by da by x is partial derivative of f with respect to x is, here it is 3x square. For y cube it is 0, and for minus 3axy it is 3y. Therefore, da by f by da by x is 3x square minus 3ay, and equate it with 0. Now partial derivative of f with respect to y is, for x cube it is 0, for y cube it is 3y square, and for 3axy it is 3ax. So can equate it with 0. Now we get two equations, and these are simultaneous equations. So after solving these equations, so to solve these equations, our first equation is 3x square minus 3ay is equals to 0. So if we cancel out 3, so it is x square minus ay equals to 0. So from this, value of y is x square x square upon 1. So substituting this value of y in our second equation, where second equation is 3y square minus 3ax is equals to 0. So value of y is x square upon a. So here it is 3 x square by a bracket square minus 3ax, cancelling 3 from both sides. Then it is x raised to 4 by a square minus ax is equals to 0. Multiplying a square, so we get here a square get cancelled, and here it is a cube. It means x raised to 4 minus a cube x is equals to 0. If we take if we take x common from both the terms, x cube minus a cube is equals to 0, which means either x is equals to 0 or this term is 0. X cube minus a cube is equals to 0. Now if x cube minus a cube is equals to 0, it implies that x is equals to a. As we are ignoring imaginary roots, we are interested only in real roots. So x cube minus a cube is equals to 0 implies that x is equals to a. So we get two values of x, that is 0 and a. Now for these values of x, we will find values of y. So for x is equals to 0, if we put this value in our equation number 1, which is this equation, so if x is 0, it means minus 3ay is equals to 0, which implies that y is equals to 0. Now for x is equals to a, if we put x is equals to a in our first equation, so it is 3a square minus 3ay is equals to 0. So cancelling 3, we get, and cancelling 3a, we get a minus y equals to 0, which means y is equals to a. So 0 0 and a are stationary points, means the points at which dabba f by dabba x and dabba f by dabba y both are 0. So these are our required points, 0 0 and a. Now we check whether these are the points of either maximum or minimum, or these are saddle points. So for this, our next and second step is calculate R, S and T. So R is partial derivative of f with respect, double partial derivative of f with respect to x. So here our first partial derivative is 3x square minus 3ay. When we again differentiate it partially with respect to x, we get 6x, and derivative of 3ay is 0. Therefore, it is 6x. For t, we will calculate partial derivative, double partial derivative of f with respect to y, that is dabba square f by dabba y square. For this is our first partial derivative. This is our first partial derivative of f with respect to y. When we differentiate it partially with respect to y again, then partial derivative is of 3y square is 6y, and this is constant term, therefore its derivative is 0, therefore value of t is 6y. Now to calculate s, this is our dabba f by dabba y. So we will differentiate that function partially with respect to x. So partial derivative of 3y square with respect to x is 0, and derivative of minus 3ax is minus 3a. Therefore, value of s is minus 3a. Now we have all the values r, s and t. Now our third step is calculate these values at given points. Calculate values of r, s, t at given points, and also calculate value of rt minus s square at that point. So at point 0 0, when we calculate rt minus s square, it is equals to 6x into 6y minus, so at point 0 0, x is equals to 0, y is equals to 0, therefore this term will get 0, and its value is minus 9a square, which is less than 0. And we have written in our rule, that working rule, that if rt minus s square is less than 0, then 0 0 is neither maximum nor minimum, which is saddle point. And at point a, if we calculate rt minus s square at point a, then x is a, y is a. Therefore, its value is 36a square minus 9a square, which is 27a square, which is always greater than 0. It's always positive. Therefore, 27a square is always greater than 0. And r is 6a. Now, if a is negative, then a is negative, then value of r is less than 0. It means rt minus a square is greater than 0 and r is less than 0. So a will become point of maximum. But if a is positive, then r will greater than 0. then RT 0 and R is also greater than 0, then point A will become point of minimum. So in this way we will find whether point 0, 0 and A are maximum point or minimum point, at what condition they will be maximum or minimum. Okay students, thank you.